In this capsule, we'll continue what we were discussing in the previous one, hybridization of carbon. We talked about how carbon hybridizes and forms 4 sp3 hybrid orbitals. This part of the screen talks about that. And in the middle portion, it's a different hybridization, and on the right side, another possibility for carbon to hybridize, and that's the versatility of carbon. It can do different hybridizations and forms different types of compounds. So we looked at the first one in an earlier capsule. So we'll erase that. So briefly, just recap before I erase. The 2s, there's one electron in the 2s. This is excited state electronic configuration of carbon. There's one electron in the 2s and one each in the 3p orbitals. At this point, they have different energies. They hybridize, and all 4 orbitals, the 2s, 2px, 2py, 2pz, hybridize and form 4 hybrid orbitals, and those are called sp3 hybrid orbitals. So sp3. So, and carbon uses those sp3 hybrid orbitals to form bonds with other elements. For example, another carbon, a hydrogen atom. So that's one possibility. Now, when carbon uses sp3 hybrid orbitals to form carbon-carbon bonds, you get the carbon-carbon single bond. Now, and all other, when carbon is sp3 hybridized, it will form bonds like this. So you see, all of them are single bonds. And this class of compounds is called alkanes, organic compounds that have only carbon-carbon bond, carbon-carbon single bonds, and carbon-hydrogen bonds are called alkanes. Now in this middle portion of the board, we have a different hybridization, which is called an sp2 hybridization. So in this one, in the sp2 hybridization, that possibility, we notice what the orbitals that hybridize are the 2s, the 2px, and 2py. So 1s orbital and 2p orbitals are hybridizing. So this is called sp2 hybridization. And when it does that, so when carbon adopts sp2 hybridization, since 3 orbitals are involved, we get 3 orbitals hybridize, and we get 3 sp2 hybrid orbitals. And then there's this unhybridized orbital, that one. There's one electron in the unhybridized p orbital. So as a result of this hybridization, the 2s, the 2px, I'll redraw that here. So the 2s, the 2px, 2py, and 2pz. So there's one electron in each of them. These are hybridizing. So the energy levels, orbitals, all become similar. For those 3, they'll form 3 degenerate hybrid orbitals. So let's just draw that here. So you get this energy scale going up, higher energy. So now since these 3 orbitals hybridized, we get hybridized orbitals, 3 of them, and they're sp2 hybrid orbitals. Each of them will have 1 electron. And then you see there is this unhybridized p orbital. The unhybridized p orbital will be slightly higher in energy. This is unhybridized p orbital. That is a slightly higher energy, and of course there's 1 electron in that. So let's take a carbon with this situation and see how that carbon forms carbon-carbon bonds, and of course carbon-hydrogen and so on. So let's take a carbon, two carbons for example, a carbon sp2 hybridized carbon, another sp2 hybridized carbon, two of them, and each of these carbons is sp2 hybridized. So each carbon will have three hybridized orbitals and one unhybridized orbital, that's the unhybridized orbital, higher energy, and that is in the pz orbital there. Anyway, so let's start with the hybridized orbitals because they are lower in energy. Start with that. So this carbon has this hybridized sp2 orbital, and this carbon also utilizes its hybridized sp2 orbital. Those are the two lobes. So these two carbons are forming a single bond initially. So you get the carbon-carbon single bond. Now let's look at this example, CH2 double bond CH2. We are explaining how this forms, this compound. So the sp2 hybrid carbons are using the sp2 hybrid orbitals to form the single bond first, and this carbon uses its hybridized sp2 orbital, and with the 1s orbital of one of these hydrogens to form the bond there, another bond, and the bond. So now, so far each carbon used the sp2 hybrid orbitals. Now, how is the double bond being formed there between the two carbon atoms? Now, notice this one, there is this unhybridized pz orbital, at higher energy, there is one electron in that, so there is this orbital there on that carbon, there is that orbital there on that carbon. We write them this way, not like this. This is the hybrid sp2 orbital, the shape of those orbitals, and the unhybrid sp orbital is in this way, and there's one electron in each of them. So they overlap, those two orbitals overlap to form the double. So that's how we get the carbon-carbon double bond. So whenever you see a carbon-carbon double bond, you know it is an sp2 hybridized carbon. So carbon, the versatility of carbon, we are seeing that it can form sp3 hybrid orbitals, which will lead to so many compounds, and then carbon can also utilize an sp2 hybridization to form carbon-carbon compound with carbon-carbon double bonds. And there's another possibility which we'll see shortly. So compounds with carbon-carbon double bonds are called alkenes, and compounds in this one we use the sp hybridization to explain how carbon forms a triple bond between the two carbons here. So each carbon here is sp hybridized. So here I have already drawn the third possibility. So in this one, this is again the excited state configuration of carbon. We have a 2s, 3 2p orbitals with different energies. In this possibility though, the 2s and the 2p, one of the 3 2p orbitals, are hybridizing. The other two 2p orbitals are not hybridizing. So these two are not hybridizing. Only these two are hybridizing. So in which case we get, again if we draw the hybridized orbitals, the two sp hybridized orbitals will be at a slightly lower energy, and the two unhybridized orbitals are at a slightly higher energy. So we have one electron in each of them. Now let's consider two carbons that are sp hybridized coming together to make a bond. So there's this carbon, there's this carbon. So initially the carbons use the hybrid orbitals, the sp hybrid orbitals, to form the carbon-carbon single bond, and two sp hybrid orbitals, right? So each carbon has another sp hybrid orbital, so that's being used to form a single bond with a hydrogen. And at this point, this carbon, both carbons, have used up the sp hybridized orbitals, but they do have two other unhybridized orbitals with one electron each on each carbon. So now the unhybridized orbitals, as we have seen in this case, in the previous case, the difference is this is an sp2 hybridized carbon. It has one, each carbon here has one unhybridized orbital. In this case, we have an sp hybridized carbon. Each carbon has two unhybridized orbitals. So the two electrons here on one carbon in py-pz orbitals, and again on this carbon py-pz orbitals, they overlap to form the double bond and then the triple bond. So that's how we get different classes of organic compounds. One type of organic compound. So I'll just put the types of organic compounds here, just for comparison, side by side. We have alkanes, alkynes, and all of them are hydrocarbons because they have only hydrogens and carbons. So alkane example could be something simple ones, CH3. The carbon here is sp3 hybridized. Here alkenes are compounds or hydrocarbons with one or more double bonds. So in this case, the carbon is sp2 hybridized, and in the case of alkynes, you have compounds like this with a triple bond, and the carbon is sp hybridized. Okay. So in the next short video, we'll take a look at the bond lengths, bond angles, bond strength, and such things. So we stop now. In this, here is a summary of different possibilities: sp3, sp2, sp, and the different types of compounds carbon can form. So we'll see you in the next video.